esok lah. Okay. Okay, jadi apa pun kita tunggu keputusan esok. Kemudian selain daripada tu, untuk makluman, kelas ini macam biasa adalah direkod dan saya akan upload di dalam YouTube YouTube channel saya, dan siapa yang tertinggal atau tak sempat follow saya punya kelas boleh rujuk semula kepada YouTube Okay, kalau saya tengok YouTube channel saya ni, nak diikutkan yang view-nya pun tak ramai Jadi saya bukannya kisah sangat pun pasal viewers ni, tapi ni menunjukkan yang menunjukkan seolah-olah pelajar tidak mengulang kaji hanya mendengar lecture dan tidak mengulang kaji di dalam, dan tidak je lah, maksudnya tak tengok YouTube tu, maksudnya tak ulang kaji lah. Pelajar-pelajar yang tak hadir kelas secara online tu. Okay. Jadi sekarang baru 30 orang. Okay, seminit lagi sebelum jam 8.30. Okay. Nampaknya semakin ramai yang baru join Okay. Jadi kalau boleh, kalau boleh tengoklah saya punya video tu supaya boleh refresh apa yang awak belajar ni secara online dan rujuk semula untuk awak punya ulang kaji Okay, untuk makluman semua, hari ni kita akan belajar mengenai operational amplifier Okay. Okay, semakin ramai yang baru join. Okay, untuk makluman, saya akan memberi lecture berkenaan dengan operational amplifier Okay. Operational amplifier. Dan hari ni saya tak dapat nak buat kelas pada waktu petang jam 2 sebab clash dengan proses menghantar proses submit soalan final kepada pihak fakulti. Okay. Jadi sekarang ni kertas soalan final tu dah ada dalam bilik kebal Jadi siapa yang akan ambil final SEM ni, diorang akan menjawab soalan yang saya hantar itu pada fakulti hari ni. Okay. Bilangan pun sudah lebih daripada separuh. Okay, saya rasa saya dah boleh mula untuk saya punya pengajaran hari ni Okay. Okay. So saya kena tunjuk slide sekejap. Stop presenting. Present now, a window. Okay, nampak ke slide?
Nampak sir, nampak.
Nampak ke slide? Okay,
nampak.
Alright. Okay. Okay, so Bismillahirrahmanirrahim. Hari ni kita akan mulakan pengajaran mengenai topik bertajuk operational amplifier So basically operational amplifier ni tujuan dia satu je, adalah untuk amplify voltage yang kita dapat voltage yang kita dapat, voltage yang kita perlukan itu kadang-kadang dia lebih daripada voltage yang masuk tu kurang, and then kita perlu amplify supaya dia boleh ikut sistem yang kita nak buat tu lah. Okay. So there are few types of amplifier. So the most common amplifier is first one is inverting amplifier, and then a non-inverting amplifier, voltage follower. Okay, the fourth one is summer. Okay, summer means a summing amplifier, and then the last one is difference amplifier. So each type of this amplifier have different arrangement. For example, the inverting amplifier, the negative side of the amplifier is connected to the voltage supply, and then for the positive type is connected to the ground. Okay, this is for the inverting amplifier. And then a little bit basic about the amplifier. Oh, ramai betul baru join jadi saya nak kena approve, lepas tu nak kena cakap lagi. Sedikit sebanyak mengganggu. Okay. So for this chapter, we will only focus on the ideal amplifier, ideal operational amplifier. So the main characteristic of the ideal amplifier, it have infinite voltage gain, and then infinite input impedance, and then zero output impedance. Okay, meaning that for impedance, there is no current that able to flow. Okay, flow at this terminal. Okay, so basically whatever the voltage is will be equal to the voltage at V2. So there is no losses okay, for ideal amplifier. However, in the real world, there are no such thing as ideal. Similar with the transformer. Okay, and then it is used, it have an infinite voltage gain. So meaning if you can increase the voltage up to whatever you can increase or amplify the voltage no matter whatever value. Okay, and then it have a infinite input impedance, so there is no losses, meaning that there is no losses in the operational amplifier. Okay, and okay, I already described the description. Then okay, for ideal op-amp, you can write the input and output using the Kirchhoff current law. So similarly, in Kirchhoff current law, you need to identify the node, okay, the terminal, okay, and then the input and the output of the current. Okay, for this basic amplifier, basically it have four. Okay, it have five current that flowing. Okay, this first one is I1, and then all of I1 to I negative is the current entering the node. Meanwhile, for output, IO is the current leaving the node. So that's why you able to get this equation. Okay. 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 Before that, this is the arrangement of the operational amplifier, it have 8. Okay, what do we call this? 8. Okay, dia punya terminal 8 terminal, which is the first one is offset null, and then second is inverting input, third is non-inverting input, and then the fourth one is the voltage supply. Okay, and then 7 is the positive voltage, then 6 is output, 8 is NC. Okay, and then the number 5 is offset null. Okay, what else? Okay, now we can start with our first type of amplifier, which is inverting amplifier. Okay, in this following section, we consider some useful op-amp circuit that often serve as module for designing more complex circuit. The first of such op-amp circuit is the inverting amplifier, as shown in the figure lah. So, okay. In this circuit, the non-inverting input is grounded at Vi. So this is the input voltage. Then, okay, the current will flow through the resistor R1 and the feedback resistor. Okay. Then the feedback resistor, which is RF, is connected between the inverting input and output. Our goal is to obtain the relationship between the input voltage Vi, okay, Vi, and the output voltage V0 by applying the Kirchhoff current law at node 1. Okay. Basically, we need to write our equation, okay, based on this, all of these parameter. So at the end of our calculation, we need to calculate the voltage output, whatever type of the amplifier. So let's start with this first type of amplifier. Okay. 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 Here we need, first thing is in KCL we need to define the node. So in this case, I define node 1 as the first node, and then node 2 as the second node. Okay. And then since the ideal transformer have no losses, so we know that V1 negative is equal to V2 positive, which is equal to, and then the current will flow to the ground, which is equal to 0. Okay, you need to write this as one of the first equation, and then we write the node equation using the KCL at node 1, at node 1. Okay, you students can do this with me together. Okay, based on this diagram, it assumes the current is flowing to the node. Okay, but usually, okay, for me, I did not like to use this current flow. So for me, I usually assume that current is leaving the node. So that is my assumption. So when the current is leaving the node, we can write current is in the opposite, which is I1. And then I2, okay, I2 current is leaving the node. Okay. I2. Okay. Okay. And then we write the the equation. Current entering the node is equal to 0. And then equal to current leaving the node. So we have the first one, which is V1 negative terminal, V1 negative minus with VI, VI over R1. Okay, plus with current to the feedback resistor, which is V1 negative, V1 negative, okay, minus V node, okay, over the feedback resistor RF. Okay, and then we need to write the equation based on this first equation. Okay, so we need to get the unknown V1 negative. So as usual in the KCL, you need to cross multiply the 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 R1 and RF. So you will have RF minus VI over, okay, this one will be R1 RF, then plus with V1 negative minus V naught times with R1. Okay. So we need to expand the equation. So we will have V1. Okay, now the next step will be bringing the R1 RF to the left hand side. So you will get 0 lah. So V1 negative RF minus VI RF plus with V1 negative R1 minus V naught R1 equal to 0. So now we factor the V1 negative and then bring VI RF and V naught R1 into right hand side. So you will get V1 negative RF plus V1 negative R1 equal to VI RF plus V naught R1. Then factor the V1 negative, you have RF minus R1. Okay. So VI RF plus V naught R1. Then V1 negative equal to VI RF plus V naught R1. Okay, over RF minus R1. Okay, so now we finish on the V1 negative. Okay, then based on this equation, we know that the V2 is equal to 0. Okay, So we can write it as V1 negative equal to V2 positive. Okay. Equal to 0 lah So V1 negative will be VIRF plus V naught R1 over RF minus R1. Okay, this one equal to 0. Okay, bring RF minus R1 into the right hand side. So it will be equal to 0. So V1 RF plus V naught R1 equal to 0. So remember that we need to calculate the output voltage. So now we need to bring the V1 RF to the right hand side. So you will have V naught R1 equal to minus V1 RF. So V naught equal to minus V1 times RF over R1. Okay. So now we get the voltage output for the inverting amplifier. Okay. 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 So we know that the voltage gain is AV. Okay. AV is the voltage gain equal to V naught over the voltage input, which is equal to feedback resistor over the resistor 1. Okay. You must remember for the arrangement of inverting amplifier, it must have this kind of uh equation. Okay, so what do we know based on this equation? We know that the value that you will get is in reverse polarity. Okay. 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 So basically, if your signal or your wave is a positive value, then it will reverse and you will get a negative value because it is reverses the polarity of the input signal while amplifying it. Okay. Okay, consider this first this okay, consider this question Okay, basically is already include with the answer include with the solution, but it's okay, we just try to solve this equation. If R1 is equal to 100 ohm and R feedback is equal to 200 ohm and voltage input is equal to 10 volt, so the output voltage after the amplification, so you will have RF is equal to 200 times with R1, which is 100 ohm, divided with sorry. Okay. Okay, V output. Okay, RF. Okay, RF is equal to 200. 200 times with voltage 1. Voltage 1 is voltage input 10 volt. Okay, don't forget the negative. Divided with R1. So R1 is equal to 100 ohm. So you will have a value of negative 12, 20 volt. So means that the inverting amplifier increase gain the voltage and up to negative 20 volt. And then it also change the polarity of the signal, okay, of the voltage. So you will get a negative 20 volt. Okay. And then the current through R1. Okay. The current through R1. If you look back at our equation, current at R1 will be equal to V1, okay, V1 negative minus VI, okay, divided with R1. R1 is equal to, okay, R1 is equal to R1 is equal to 100 ohm. Okay, 100 ohm. Okay, VI negative is equal to 0. So negative voltage input is equal to 10 volt. Okay, 10 divided with 100. Okay, which is equal to negative 0.1 ampere. Okay. Why do you get negative? Okay. It's just because your assumption. Because you assume the current is leaving the node. So that's why you get a negative 0.1 ampere. Okay. Negative 0.1 ampere. Okay. You can further write it. This is based on our direction of current flow. Okay. Basically, in a circuit, we don't know the current is coming from which voltage supply. Okay, so at the beginning, we need to assume. Okay, so this is based on our assumption. Okay, now we okay, I want you to try to solve this example. Wait a moment. I want you to try to solve this example. Okay. Try to solve this example. I give you 10 minutes. Okay, I want you to try to develop the equation, okay, to get the voltage output. Okay, I don't want you to directly use the formula. Okay, derive from the beginning. Okay, okay, I give you 10 minutes until 9:10. Saya nak dengar suara sikit Tiada yang tidur ke? Amira, faham ke? Amira, boleh bersuara sikit? Okay. Cik Amir, faham ke? Okay, sambil-sambil kamu buat latihan tu, saya nak bagi tahu yang kita sebenarnya, saya sebenarnya sangat, bukanlah sangat maksudnya saya caring pasal kamu. And then saya tak nak mana-mana student saya ni terlepas final Okay, siapa yang sepatutnya ambil final tu, saya minta supaya betul. Saya sendiri pun akan usaha untuk make sure kamu ambil final. Tapi saya minta juga inisiatif sendiri daripada pelajar-pelajar. Okay, untuk confirmkan sama ada nama kamu tu betul-betul ada untuk ambil exam final SEM ni atau tak Sebab saya ada student lebih kurang 100 orang Maksudnya campur dengan statik dengan elektrik ni 50 orang. Jadi saya tak boleh nak pergi seorang-seorang, one by one tu. Saya tak boleh nak buat macam tu. Okay. Jadi saya minta supaya kamu untuk make sure yang kamu tu sebenarnya ambil final bila. Okay. Kemudian saya sendiri pun sentiasa keep on track. Okay. So sekarang ni sebenarnya saya tengah keep track untuk student yang sepatutnya ambil final SEM ni supaya tak terlepas lah tarikh tu. Okay, lagi-lagi untuk pelajar-pelajar yang kena ambil final, kena pergi latihan industri selepas SEM ni. Okay, kalau dia tak lulus subjek ni, maksudnya kamu tidak dibenarkan untuk membuat latihan industri. Okay, kena tunggu pula. Maybe SEM depan lah sekurang-kurangnya. Okay, bulan 2 tu. Jadi, saya minta supaya kamu semua alert. Saya sendiri pun dah minta senarai nama daripada KP untuk betul-betul pastikan yang pelajar-pelajar saya ni tak terlepas dari final exam. Okay. Okay. Okay, Muhammad Hazim. Dah dapat ke jawapannya?
Belum tu, belum.
Okay, buat Okay, kita ada banyak lagi kita kena discuss ni. Kita ada summing amplifier, kita ada non-inverting amplifier. Okay, kita ada differential amplifier. Okay. Mungkin kelas ni habis pukul 12 lah aku Okay, Hasifi baru join kelas ni, jadi saya minta Hasifi untuk cuba selesaikan example yang saya bagi dalam SketchUp tu Afif Izra ni macam mana boleh ada dua Negatif 120K. Sekejap, sabar sekejap. Negatif 120 milivolt bukan K. Okay, betul. Terbaik. Kamu okay, Aizat Hilmi ni Akil Najmi. Macam mana boleh dapat K Okay, 8 microampere. Okay, terbaik Fahmi Osman. Oh, alright. So the answer for the voltage output is negative 120 millivolt, and for the current is 8 microampere Okay. So kamu derive daripada awal ke? Akil Najmi, Aizat Hilmi, Syahrul Rizan bin Said. Tak faham Tak faham. Siapa tak faham? Tak ada yang menyaut pun. Maksudnya semua faham ni. Nurin Nadia, saya guna formula tak dapat. Okay. Sepatutnya dapat Sir, saya macam dari awal tak faham. Tak faham sir, okay. Apa tak faham? Semua tak faham ni. Nurin Nadia. Dia okay, boleh guna directly formula. Tapi saya encourage student untuk derive. Okay. Sebab dalam final arrangement dia adalah berbeza. Dia takkan dah straightforward macam ni. Okay So nampak gayanya saya kena tunjuk lah Okay, untuk siapa-siapa yang tak faham tu, saya tunjuk Okay, first kali kita assume the first note is kita ini macam mana pun kita tengok kita dah tahu sebab note ni ada lebih daripada 2 elemen So we know that this is the first note. Okay. So from the based on the current flow, okay, we know that it will go to the negative terminal, to the positive terminal, and then grounded to the earth, bukan earth lah, ground, ground, So from here we can write one equation which is V negative equal to V positive, and then V positive is connected to the ground, which is equal to 0. And then we write the first KCL at node V1 negative. So here I name it as V negative. Okay. So at node V negative, we assume the current is leaving the node. Okay, leaving the node. Okay. Current is leaving the node. So based on the Kirchhoff current law, current entering the node is equal to current leaving the node. Okay. So assume here is I1 and then this is I2. Okay. Current entering the node is none. Okay, so its mean equal to 0. Then current entering the node is current leaving the node I1 plus with I2. Okay. For I1 and I2, we know that I is equal to V over R. Okay. Then current is flowing to the voltage, which is 40 millivolt. So let's assume that the voltage here is higher than voltage at 40 millivolt. So you can write it. The expression for I1 is V negative minus with 40 millivolt. Okay. Flowing through 5 kilo ohm divided by 5K. And then plus with I2, which is V negative minus V, it go to the output voltage divided by 15 kilo ohm. Okay. Okay, so now what we need to do is to rearrange the equation lah macam biasa. So for this arrangement, I times with 3. Why? Because it is equal to this part of equation. Okay, if the below part I multiply with 3, so meaning the up part of the equation also I will times it with 3. Okay, so you will have a value of 3V negative minus 40 times 3, 40, 80, 120, plus with V negative minus V naught equal to divided with 15 kilo ohm. Okay. Bring 15 kilo ohm to the left hand side. So you will have a 3V negative minus 120 plus, okay. Okay. So bring it to the left hand side. So you will have, okay, the 4, 4V negative minus 120 minus V naught equal to 0. Okay, now, okay, based on this equation, we know that V negative is equal to V positive, and then V positive is grounded. So it is equal to 0. So now substitute with 0. So you will have minus 120 minus V naught equal to 0. Okay, maybe I'll... Okay, so don't forget to write millivolt okay, at the end of the answer. So V naught is equal to negative 120 millivolt. Okay. And then what else? Calculate the current through the feedback resistor. So in this case, the feedback resistor in this equation is at this part. So RF is equal to V negative minus V naught, okay, I at RF equal to V negative minus V naught divided with 15 kilo ohm, okay, equal to, we already calculate the output of the voltage. So you will, this output of the voltage equal to negative 120 millivolt. And then for V negative, it is equal to the grounded, which is equal to 0. So negative V output negative 120 milli divided with 15K. So you will get the answer equal to 8 microampere. Okay. So now, do you understand? Okay. Dapat dah? Okay, Nuri Nadia dapat So siapa yang Wafi Saidi, saya tak faham. Saya tak faham kurang. Wafi Saidi baru bangun tidur ke? Understand sir okay. Wafi? Okay Wafi Next example Wafi kena buat Wafi kena present Okay, so sekarang kita move to the next type of amplifier. Okay. Next type of amplifier will be okay, so dah dalam 40 orang, ada lagi CV, Itihad. Okay, sekarang kita teruskan kepada summing amplifier. So beside amplification, the op-amp can perform addition and subtraction. The addition is performed by the summing amplifier covered in the section. The subtraction is performed by the difference amplifier covered in the next section. So, okay, let's move on. Basically, this is the summing amplifier. Okay, for a summing amplifier, you can see that there is a multiple of amplifier is connected to the node A, and then the node A is connected to the voltage at the negative terminal. Okay, so basically for V1, V2, and V3, it can be different type of amplifier. Okay, for this part, it only shows a voltage follower. Okay, but the the question, or in the real world, it can be a difference amplifier, and then maybe inverting amplifier or non-inverting amplifier connected, okay, at V1 or V2 or V3. Okay. So basically it is a combination of various type of amplifier. Okay. In this case, in order to make sure that the student understand the principle of the summing amplifier, so that's why it's using a voltage follower. Okay. A, a component of voltage follower. Okay. Okay. So now I will show you the derivation. Okay. Before I start with the derivation part, I want you to know why derivation is very important. Okay, because based on the derivation, it will show you that you understand the concept of the amplifier. So I always prefer student to do the derivation before they memorize the formula. Okay. Okay, as usual, we need to calculate the voltage output. Okay, so we need to derive the equation based on the, you must include the voltage output. Okay, so the first thing that we know based on this um, amplifier is that, okay, note a voltage at A, which is VA negative, is connected to the negative terminal. Okay, negative means it is connected to the negative terminal, and then equal to the voltage positive, and then the voltage positive is connected to the ground. Okay, and then we need to develop the equation based on this. This yeah, we can say based on this definition. Okay, based on the circuit lah. Okay, the circuit. Okay, so based on the circuit, this is how it can be presented. Okay, then at VA, we know that the current is basically leaving the node. So the same thing, current is leaving the node. Okay, VA, current is leaving the node. Okay, you can take 2 points here. Okay, first you do it at here, and then here. Okay, okay, current is leaving the node. So here current also leaving the node. Okay, we can write it as, okay, this is I1, I2, I3, and I. Okay, so all of the current is leaving the node. There's no current entering the node. So 0 equals to I1 plus I2 plus with I3 plus with IA. Okay, now now we expand the equation because we know that I is equal to voltage over resistance is 0. I1 will be V A minus V1 over R1 plus VA minus minus V2 over R2 plus VA minus V3 over R3. Okay, and then plus VA plus minus V0 over feedback resistor. Okay, and then there's no current entering to this negative terminal. So there will be no equation over here. Okay. Daniel Akil baru join balik Okay, so sekarang ni kita proceed kepada summing amplifier. Okay, so for V positive, there will be no equation because it is directly grounded. Okay. So we know that VA negative is equal to 0. So 0 is equal to negative V1 over R1 plus with negative V2 over R2 negative V3 over R3. Okay, VA minus V0 over RF. Okay, then I will bring V0 over feedback resistor to the left hand side. So we will have V0 over RF equal to negative V1 over R1 minus V2 over R2 minus V3 over R3. So the voltage output is equal to negative V1 RF over R1 minus V2 RF over R2 minus V3 RF over R3. Okay. So simple. This is the formula for the summing amplifier. Okay. I will give you one example, but I will make it as assignment. You will submit it into the assignment port. Okay. Take this as your assignment. Calculate V0, I0 in the op-amp circuit in the figure. Okay, I just wanna repeat. Okay, for summing amplifier, it can be anything. Okay, in this case, it use this kind of circuit, but it also can come with different type of amplifier that connected to the negative part. So it can be inverting, it can be non-inverting, it can be voltage follower. Okay. So you must know the derivation. So it will be much more easier for you to calculate the output of the voltage. Okay. Okay. This is the assignment. Okay. Now I will proceed to the next type of amplifier. Okay. Okay. You also can try to solve this problem. Okay. Now we proceed to the next type of amplifier. Okay, for non-inverting amplifier, you are presenting. Okay, for non-inverting amplifier. Okay, another important application of the op-amp is the non-inverting amplifier, shown in figure 5.16. In this case, the input voltage Vi is applied directly at the non-inverting input terminal, and resistor R1 is connected between the ground and the inverting terminal. We are interested in the output voltage and the voltage gain. Okay. So now I will copy you the okay. I will copy you the figure and we do the derivation. Okay. Okay. For a non-inverting amplifier, you will realize that the positive terminal is connected to the voltage supply. And then for terminal V negative, it is connected to the ground. Okay. So here we determine the node. Okay. The node at V1. Okay. So this is considered as the node V1 lah. Okay, but before that, we need to write V1 negative is equal to V2 positive, and then V2 positive is equal to Vi.
Sir. Gelak sir.
Ya?
Tak ada
Sir gelak, sir.
slide.
Okay. Sekejap. Okay. Alright. Okay, so saya ulang balik. For a non-inverting amplifier, the positive terminal is connected to the voltage input, which is ni lah voltage input. Okay, and then V1, okay, V1 negative terminal is connected to the ground. So from here, okay, I assume that all of the current is leaving the node. So current leaving the node. Okay, so you write the equation at node V1. Okay, write the KCL equation. V1 minus Okay, it go to the ground. So minus 0 divided with R1. Okay, and then plus with V1 minus V0 over RF. And then equal to 0. Why? There is no current that will enter the node. Then this is for node at V1. For node at V2, okay, not node at V2, it is equal to Vi. Okay, so okay, back to the node V1, we need to rearrange the equation. Multiply R1 with RF, and then RF multiply with R1. So V1 times with RF plus with V1 minus V0 multiply with R1 divided with R1 RF equal to 0. Bring R1 RF to the right hand side, then you will have a okay, V1 negative. Okay, you will have a 0, V1 negative. Okay, V1 negative. So V1 negative RF plus with V1 negative R1 minus V0 R1 equal to 0. And then factor V1 negative, and then bring V0 R1 to the right hand side. So you will have RF plus R1 equal to V0 R1. Okay. V1 negative is equal to V0 R1 over RF plus R1. Okay. Then what else? V1 negative is equal to V2 positive equal to Vi. Okay. So Vi. Don't forget Vi. Okay. So now V1 positive is V0 R1 over RF plus R1 equal to Vi. Okay, Vi. Then V0 R1 equal to Vi RF plus R1. Then V0 is equal to Vi RF plus R1 over R1. Okay. Then so R1 equal to 1 plus RF over R1. Okay, sorry, Vi. Please make sure you include the voltage input. Okay, so for the non-inverting amplifier, this will be the equation for the voltage output. Okay, if you will get this similar type of non-inverting amplifier, so that's no problem. You can directly use the formula. But if you will get a little bit complex of equation, so you need to develop it from scratch. So this is the non-inverting amplifier. Okay. Okay, bateri saya nak habis sekejap Saya ambil bateri sekejap. Saya ambil power supply. Okay. 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 Sebenarnya dalam note ni tak banyak contoh lah. Saya okay. So based on the derivation, okay, apa yang kita tahu, what we will know about the principle of the non-inverting amplifier is that the voltage gain, okay, does not have a negative sign. Thus the output has the same polarity as the input. Okay. So polarity dia adalah sama, okay, dengan input. Okay. So now we move to our last type of charge amplifier. Okay. Amplifier. Okay. Which is differential amplifier. Okay. This is the differential amplifier. Okay, as you can see, the negative terminal is connected to the voltage supply, and then the positive terminal also connected to the power supply, and then it's also connected to the ground. So this type of amplifier is considered as a differential amplifier. Okay. Again, similarly, we need to derive the equation based on the Kirchhoff current law. So in this case, I will take this as the first node, and then this is the second node. So this is node V negative, and then this is node V positive. Okay, for this case, okay, basically V negative is equal to V positive. That's it. Okay. And then V negative apply at node V negative. Okay. V negative minus V1 divided by R1 plus with V negative minus V0. V0 over R2. Okay. Okay, this is the current flow. Okay. And then equal to 0. Okay, why? Because there is no current entering the node. Okay. Then, okay, rearrange the equation. So you will have multiply R1 with R2 and then R2 with R1. Okay, bring to the right hand side for R1 and R2. So V negative minus V1. Okay, I will directly expand the equation. Okay, I bring V1 R2 and V0 R1 to the right hand side. Then I factor V negative. Divided with R2 plus R1. Okay. Now for V positive, okay, add note V okay. Current is leaving the node. Okay. There is no current entering the node. Okay, so V positive minus V2 over R1 plus with V positive minus R2. Sorry. Okay, V positive going to the ground. Okay, minus with 0 divided with R2 equal to 0. Okay, multiply both R1 and R2. Bring R1, R2 to the right hand side. Okay, bring V2, R2 to the right hand side. Okay, factor V positive R1 plus R2 equal to V2 R2. So V positive is equal to V2 R2 over R1 plus R2. Okay, so back to our previous relationship between V1, V negative with V positive. So V negative is equal to V positive. V1 R2 plus V not R1 over R2 R plus with R1 equal to V2 R2 over R1 plus R2. Okay. Remember that we need to calculate the V output. So here we need the V output. So bring R2 plus R1 to the right hand side. So we will have V1 R2 plus V not R1 equal to V2 R2 over R1 plus R2 times with R1 plus R2. Okay, we can cancel out these two. So V1 R2 plus V0 R1 equal to V2 R2. Okay, V0 R1 equal to V2 R2 or minus. Okay, so V0 V output equal to V2 R2 minus V1 R2 divided to R1. Okay, so from here, okay, okay, kita factor, you need to factor the R2, okay, R2 over R1 equal to V2 minus V1. Okay, so for voltage output for this type of amplifier is equal to, will be this formula. Okay, okay, before I end this class, I want to show you. Okay, okay, nampak slide Okay, basically in operational amplifier, this is your Bible. So this is your Bible. You must make sure that at the end of the derivation, you get the right output that refer to your particular operational amplifier. Okay. So based on all of our derivation previously, okay, this is what I derived from the beginning of this class until the last one, which is the difference amplifier. So this formula will not be given in the final. Okay, you need to derive on you have actually two method. The first one is to memorize, and then the second method is to derive. So it's up to you to choose which method that suitable for you. But for me, I always prefer to derive from the beginning, so that I get the output of the operational amplifier. Okay, I will upload several assignment for you for practice. Okay, and then I will also discuss. Okay, for all of the type of amplifier, so that you will be familiarized with different arrangement of amplifier. Okay, before I end this session, okay, saya nak tanya, susah ke? Boleh seorang wakil jawab ke? Susah ke?
Tak susah ke? Confused sikit lah.
Okay, tak susah sebenarnya apa-apa pun calculate dia punya output tu je. Okay. Yes. Leceh leceh, and then basically kena kuatkan mathematics lah. Okay, untuk soalan final, basically kalau kamu boleh sampai tahap derivation tu, maksudnya okay sangat lah. Okay, maksudnya dah no problem lah untuk kamu jawab final tu. Okay, tapi saya ingatkan supaya jangan belajar untuk final. Try belajar untuk improve diri punya knowledge. Itu lagi baik untuk kamu punya masa depan. Okay, ada apa-apa soalan ke untuk tanya? Saya boleh explain. Okay, jangan lupa lab. Kita ada lagi 3 minggu. Minggu ni saya akan siapkan bipolar junction transistor. And then next week saya akan bagi DC motor. Okay. Farah, ada apa-apa soalan ke? Okay. Boleh tak pelajar yang mengulang untuk apa stay kejap maybe kita ada discussion sikit. Saya nak 10 orang yang letak nama sebagai pelajar mengulang tu supaya stay sekejap Okay. Yang lain tu boleh dismiss Okay. That's all for today. See you again in our next class. And then if you have any enquiries or anything you want to ask, you can WhatsApp me. I apologize if I cannot entertain all of the inquiries because sometimes I did not have enough time to entertain all of the students. Okay, but I will try my best to deliver the best the best way to make you understand. Okay, that's all. See you next time. Assalamualaikum.